Alien Matter in the Solar System, a Galactic Mismatch, presented by Science at NASA. This just in. The solar system is different from the space just outside it. Researchers announced the finding at a press conference on January 31, 2012. It's based on data from NASA's IBEX spacecraft, which is able to sample material flowing into the solar system from interstellar space. We've detected alien matter that came into our solar system from other parts of the galaxy, and chemically speaking, it's not exactly like what we find here at home, says David McComas, the principal investigator for IBEX at the Southwest Research Institute in San Antonio, Texas. Our solar system is surrounded by a magnetic bubble called the heliosphere that separates us from the rest of the Milky Way. Outside the heliosphere lies the realm of the stars, or interstellar space. Inside lies the sun and all the planets. The sun blows this vast magnetic bubble using the solar wind to inflate the sun's own magnetic field. It's a good thing. The heliosphere helps protect us from cosmic rays that would otherwise penetrate the solar system. Launched in 2008, the IBEX spacecraft spins in Earth's orbit, scanning the entire sky. IBEX's special trick is detecting neutral atoms that slip through the heliosphere's magnetic defenses. Without actually exiting the solar system, IBEX is able to sample the galaxy outside. The first 2 years of counting these alien atoms have led to some interesting conclusions. We've directly measured 4 separate types of atoms from interstellar space, and the composition just doesn't match up with what we see in the solar system, says Eric Christian, mission scientist for IBEX at NASA's Goddard Space Flight Center in Greenbelt, Maryland. In a series of 6 science papers appearing in the Astrophysical Journal, the IBEX team reported that for every 20 neon atoms in the galactic wind, there are 74 oxygen atoms. In our own solar system, however, for every 20 neon atoms, there are 111 oxygen atoms. That translates to more oxygen in any given slice of the solar system than in local interstellar space. Where did the extra oxygen come from? There are at least 2 possibilities, says McComas. Either the solar system evolved in a separate, more oxygen-rich part of the galaxy than where we currently reside, or a great deal of critical, life-giving oxygen lies trapped in interstellar dust grains or ices, unable to move freely throughout space, and thus undetectable by IBEX. Either way, this affects scientific models of how our solar system and life formed. It's a real puzzle. While IBEX samples alien atoms from Earth's orbit, NASA's Voyager spacecraft have been traveling to the edge of the heliosphere for nearly 40 years, and they could soon find themselves on the outside looking in. Researchers expect Voyager 1 to exit the solar system within the next few years. The new data from IBEX suggests the Voyagers are heading for a new frontier indeed. For more news from the edge of the solar system and beyond, visit science.nasa.gov.